Hi, welcome to sections 3.1 and 3.2. In these sections, we're going to continue talking about angles and parallel lines. So we're going to take what we learned in chapter 2 and we're just going to extend it a little bit. So I'm going to start out by looking at this task. So if I click on it, it brings me here. Okay, and we're just going to run through it really quick. You can read through it if you want. You could play with it. This is just a GeoGebra thing that I put together. So here I got this triangle, and I'm going to look at angle B here. And angle B is 97.11 degrees. So if I take and I move angle B and I move it up to angle A, okay, so now I've got 97.1 and 45 next to each other, and then I move angle C over, I can see that a straight line is formed. So all I was doing is playing around to see that the angle sum of a triangle is 180 degrees. We did activity like that in class, so we're not going to spend a lot of time with that. The same idea here. I have my 90-degree angle. If I rotate and move my angles over so that they come together, they're going to form a straight line. Angle sum of a triangle is 180 degrees. Okay, now here we have an isosceles triangle, and all I want to show is that the angle measures are the same. So if I fold it over like this, I can see that those angles will be exactly the same. They're going to be 75.93 degrees. Okay, so I'm just playing with that a little bit. Here I have a parallelogram, and I want to show that opposite angles are the same. So if I uncheck it to fold it, it folds in half. I can check to see if the measures are the same, and they are. I can also do the other measures and see that those are also the same. Okay, opposite angles are the same. Okay, in this one, we've got a set of parallel lines. So in this case, we're forming a trapezoid. And here I'm showing that the interior angles will add up to 180 degrees. So if I fold this over, I can see that angle, basically angle A is 61.49 and angle C flips down and they form 180 degrees, and I can do the same on the other side. Flip it, and as it rotates, it also forms 180 degrees altogether. Okay, so those were some review things that we learned in the other chapter. If we look at parallel lines, okay, so here I'm looking at complementary angles. They're in the exact same spot. Doesn't matter if I move things around. So, oops. I can see that if I move A and B, as long as they stay parallel to each other, they're going to always be the same. Okay. All right, now here I've got a set of parallel lines and a transversal, which is H. And I'm going to, so I can see it. If I take this angle and rotate it, I can see that those are alternate interior. They are exactly the same. Alternate interior. And those are a couple different things. Okay. And that looks good for now. So let's go back to our notes here, and we are going to review a couple things that we know. We're going to review using angle properties to find missing angles, and then use properties of parallel lines to find missing angles. So really quick review here. I'm going to review what vertical angles are. If we have two lines that intersect, their opposite angles are congruent, so A is equal to B. Okay. The sum of adjacent angles on a straight line. So let's say I have adjacent angles. Adjacent angles are angles that share a vertex and a side. So we'll call this angle A, and we'll call this angle B. So they're adjacent because here's their vertex. Here's the side that they share. If they form a straight line, then they are 180 degrees. So the sum of adjacent angles on a straight line is equal to 180 degrees. So in this case, A plus B equals 180 degrees. Okay, now we're going to talk about adjacent angles at a point. So let's say I have a point. And here's one angle. We'll call that angle A. And let's just say if we go all the way around, and let's call that big angle B, then A plus B equals 360, because all the way around. You can have more than 2 angles. You can have 3. So we can, let's say that this is angle B, and let's say that this is angle C. So angle C would land right here. And so if I say I have A plus B plus C is equal to 360 degrees, because that's angles at a point. Okay. Some quick things to remember. So with that said, I've got this picture and I want to find x. Okay. So here's my point. Okay, what I'm going to do here is I'm going to label this A, I'm going to label this B because they're missing. And I'm going to look at the first thing that I see. What do I notice? Well, if I look at A, I can see that A plus 75 will give me 180 degrees because they form this straight line right there. And so I'm going to say A plus 75 is equal to 180 degrees, and that's because of angles on a line. And if we go back to our theorem sheet, angles on a line is number 3. And so that's where you would find that. Okay. So then I do some algebra and I subtract my 75 from both sides. And I have A is equal to 105 degrees. Okay. So I'm going to put that in here. That's equal to 105 degrees. Okay. I'm going to use a different color. And there's a couple different things you can do. You could say that, well, B is equal to 105 because it's vertical. That's fine. But what I'm going to actually do is I'm going to look right here. I've got this straight line right there that I kind of highlighted in red a little bit. And I'm going to use that idea. I'm going to say, well, I have this 105 degrees. I have 3x. And I have 15. Those 3 angles together also form 180 degrees. And the same reason, because of angles on a line. So then I just solve for x. So I'm going to subtract 105. And so I get 3x plus 15 is equal to 75. And then I subtract 15. And I get 3x is equal to 60. Divide by 3, so x is equal to 20 degrees. And that's my answer for that proof. All right, let's look at what's next. Here we're talking about parallel lines. Okay, so parallel lines is a set of lines that never touch. They go on forever. So we're going to say L and M. So we're saying L is parallel to M. And a lot of times what we do is we take a set of parallel lines and we put a transversal through it to make the transversal a different color. So there's my transversal. And so I'm going to label some letters. So I got A, B, C, D, E, F, G, and H. Okay. Corresponding angles, and if I look at my picture up above, corresponding angles would be angles that are in the exact same spot. So if I look at A, if I slide it up to E, we're saying that angle A is congruent to angle E because those are corresponding. Another set of corresponding angles would be angle B is congruent to angle F. And so what that means is they have the same measure. And then we've got angle C corresponds to angle G, and they're congruent. And angle D corresponds to angle H, which makes them congruent. Corresponding angles. So I always think of same spot. Okay, we already talked about that. Okay, interior angles. The interior angles would be the inside of the parallel line. So C, D, E, and F would be interior. And so alternate interior would be angles that are alternate of each other. So angle C is alternate to angle E, which they are congruent, and angle D is alternate to angle F, and they are congruent. So with that information, we are going to find the value of x. And so I'll write some information here. So we are given these two parallel lines, and these little arrows right here represent parallel. Okay, so I'm going to say, well, L is parallel to M, and that's because it's given. And just like we can write stuff in, we can also extend lines or draw lines in. So I'm going to get red here. And what I am going to do is extend my line. We can always extend lines, that's fine. Extend that line. See if that does anything. Okay, I think we can get somewhere. I'm going to label this A, and I'm going to label this B, and I'm going to label this C. Now there's other things you can do. This is not the only thing you can do. You can extend other lines, or you can draw more things in. But this is just one way of solving this problem. Okay. So the first thing I want to do is, do I see anything? Well, if I look carefully here, 75 plus A is 180. So I'm going to say 75 plus A is equal to 180. And that's because of angles on a line. Subtract 75, so A is equal to 105. Okay. All right, well, I'm given this 37, and here's my transversal. So if I look here, B and 37, they're corresponding angles. So 3. B equals 37 degrees because of corresponding angles. They're in the same spot. So B is equal to 30. Okay, now we can find C. So we know that 30 plus 105 plus C is equal to 180, and that's because of angle sum of a triangle. So then C is equal to 45 degrees. Okay, so this is 45. And so then, since C is 45, then that means X is 45. And that's because of vertical angles. Okay, and that is how you would write that proof. And that concludes our notes for those two sections. Thank you.